Hi friends, welcome to my channel. Let's have a look at problem 518, coin change 2. So this problem for sure is a continuation of problem 322. So in this video, we are going to practice dynamic programming solution again. So we choose to use cache or not. So we are going to present two formats of solution. So this problem asks us to return the number of combinations that make up a certain amount. So in problem 322, so we are required to return the minimum number of coins needed to break an amount. So that's actually the difference in return for these two problems. So here we want to mention that so each of the coin can be used multiple times. So this can be seen from example 1 in particular. So the constraints on this problem is the following. First, the coins array can have a length up to 300, and all the values of coins are unique, and the amount is bounded above by 5,000. So with that said, let's look at the solutions. So here the solutions are all in the format of DP, but it depends on if we use cache or not. So there are two formats of solutions. So our plan is the following. First, we're going to write a DP format with cache. So this solution actually is routine. The interpretation is very straightforward. So we shall use a hyperfunction with cache functionality here. And the second is that we want to write a DP format with tabulation. So the DP update rule in this case is actually very intuitive. So if we consider the DP table and interpret the generic element DPI as the number of ways to break amount I, then the update rule is simple based on the following line. So if there are DPI minus coin ways to break the amount I minus coin, then each of these ways corresponds to a way to break the amount I by just adding the denomination coin, right? So this will induce this update rule. So that's the plan. So next is some suggestion. First, actually we can compare the problem here with the coin change problem 322. And secondly, so we can compare the current problem with the combination sum problems. So actually there are 4 of such problems in Leetcode. So you are welcome to check out those videos in my channel or playlist. So with that said, let's look at the solution formats. So we are going to give a line-by-line explanation and the interpretations and why we write in such a format. So first, let's look at the DP with cache. So in other words, we use memorization. So for this, first I'm going to define a hyperfunction. So this hyperfunction will compute how many ways to break its target sum or total. So I'm going to define this function as f. So it accepts 3 arguments. So one is the index. So another is the total. So this is the amount we want to break. And third one is a cache. So we are going to set a default value as going to be an empty dictionary. So dictionary is mutable in Python. So we can update the state of this variable cache. So what's the role of this function? It's going to find number of ways to break total. So using cons starting from I, right? So this is the interpretation of this function. So again, as in the previous video for coin change 322, so we are going to write some stop conditions. First, if total equals 0, so we are going to return 1. So in other words, there's only one way, right? But notice that the cons is always greater than or equal to 1. So this one way means actually impossible, or it corresponding to form a base case in the DP update rule. So you can interpret it like this. So if total is less than 0, or I is equal to the length of coins, so you can change this equal to greater than or equal to. It's the same. In other words, auto bound. So we're going to return 0. So this is the one case. Another case is that if total and I in the cache, then we're going to return cache total and I. So this means that there are this number of ways to break total using the coins starting from coins I, right? So this is the interpretation. So for this, there are 3 stop conditions. So next is the genuine work. So we are going to set cache total I, right? So this actually consists of 2 parts. The first part is that if we still using this current coin, so we are going to use total minus coins I. So we want to use this current coin once. So then the total is shrinked by this amount, and then we are going to use the current state of cache, right? So this is the one possibility. Another possibility is that we are going to use the next coins. So we're going to change this to be I plus 1, and then we do not use the current coin. So this is still total, and then we use this cache. So this is the set for this total I key in the cache. So with that set, we're ready to return the cache the same amount. So if we compare the hyperfunction here with the hyperfunction in CoinChange 322, we notice that there's one additional argument. So, and this is the update rule. The reason we use this extra index is to avoid repetition in counting. So with that said, we are ready to do the return. So for do the return, actually, we'll prepare result. So first, I'm going to sort this one. So basically, I want to sort in the reverse direction. So this way, actually, we can first look at the larger ones, which with the purpose, or hopefully we can accelerate the procedure a little bit. Then what we're going to return is nothing but if we use all the coins and we want to break the amount, and the cache is because we use a default that is empty, so we do not need to specify here. But if you like, you can specify here. So that's the one solution format. Let's do a special case check. Yeah, it passes this special case. Now let's do a generic case check. Yeah, it passes a generic case. I guess that's about it for this format of solution. Now let's look at another format of solution. So let's call this solution V1 and do another one with tabulation. So in this one, so we're going to first initialize a DP table. So we're going to use DP0 times the amount plus 1. Right. So notice the interpretation, right? So DPI is the number of ways to break amount I. So we'll first set DP0. So there's we want to set it to be 1. So meaning that you can interpret that there's only one way. That is impossible. So if we forcefully interpret, actually the way we use DP0 equals 1 is more or less to use it as a base case. So that's the set or preparation. So next we're going to update. So for coin in coins, then we check those amounts. So for I in range coin and up to amount. So we are going to write amount plus 1. Then look at this. If I equals con, right, it means that there is one way, right? So if we compute I minus con, is corresponding to dp0. That's why we set dp0 equals 1. Another hint. So then we can do the update. So dpi, so dp I minus con. So notice that in this for loop, I is greater than or equal to I. So this is the increment based on the instruction here. So that's it. So then we are going to return dp amount or dp negative 1. So that's the solution with dp tabulation. So let's do a special case check. Yeah, it passes the special case. Now let's do the generic case. Yeah, it passes all the generic case. So I guess for this video and for these two formats of solution, that's about it. Thank you very much